True, true.
All right. Use the normal probability applet to find the combined area under standard normal curve that is right z 1.358. So I'm going to run that in there real fast. Okay, so 1.358. And the left is the same. And then to find the combined area. So are we looking for the area in between?
I think it's on the area of the outside.
Yeah.
Wait, let's see. Yeah, I think it's the outside because it's the right of the positive,
Yeah, so
left of the negative.
yeah, 0.1745.
Yeah. That's what I got.
Round it up to 0.175.
Oh, yeah.
Oh, you got around 3 places.
Agreed.
Okay. All right. Which of the following will have a smaller standard deviation? If 9 observations are randomly drawn from a population, the distribution of individual observations, the distribution of sample means, or this cannot be determined from the given data. And I would say the distribution of sample means.
Let's see.
I would agree with that.
Because I'm not sure why I think that. I just think that. Is it because the individual observations are the sample, but the mean's always going to be the mean?
Oh, that one's kind of hard to explain.
I'm almost going with the this cannot be determined, but I'm not 100% sure.
9 observations, so it's a small sample.
Mm-hmm.
Yeah.
Smaller standard deviation.
Which one of this one? Well, if we did the individual observations, that's like the population, right? And so with the, I think with the equation, you have to do the observation minus the mean and then divide it by the normal standard deviation by the square root of the sample.
Mm-hmm.
So I think it gets smaller because of all the division. So I think you're right, but
Or you don't have to divide to get the sample means,
oh, wait, let's see here.
right? Isn't the mean just the mean?
Mm-hmm.
Yeah. Oh, yeah, you're right. Okay, which of the following would have a smaller standard deviation? Well, so if for the individual means, you don't have to divide it by the square root of 9, but with the sample means, you have to divide it by the square root of 9 because it's a sample, right? So the individual would be bigger.
Yes, I get you.
Because it doesn't have to be divided by the square root of 9.
Okay, that makes sense to me.
Yeah.
That.
I agree.
Okay,
Cool.
let's go with it.
Okay.
I'll submit it first, and if we get it wrong, you guys can.
But we can submit it twice, right? It'll tell us.
Oh,
Yeah.
that's true, yeah, too. Let's see.
So is it my turn?
I think it's Devin's turn.
Okay.
Okay. Sorry. Which of the following results implies that the spread in X decreases as the sample size increases? So, okay. I think this is, okay, the spread is based on the law of large numbers. So the answer is law of large numbers.
I agree.
I agree with that too.
Okay. Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed. with a mean of 150.8 and a standard deviation of 8.8. Question number 6. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So the z-score would be her score, which is 160. Let's see. So it's 160 minus the mean, which is 150.8, divided by the standard deviation of 8.8. So let's see. So I got a z-score of, so it says round to 3 decimal places. So mine would be 1.045.
That's what I got.
Yeah, that's what I got.
Okay.
Agreed. That's what I got. Is it my turn?
Yep.
Okay. What is the probability that a randomly selected student will score above 160 on the GRE? So we just need to put that 1.045 into our normal probability. And the chance of scoring above that, I got 0.148.
That's what I got.
That's what I got.
Sweet.
Okay. Sweet. A random sample of 5 students was selected to take the GRE. These are their scores. What is the z-score corresponding to the sample mean of these students' scores? So we just need the mean of all these scores, right?
Okay. Yeah, I'm pretty sure it is.
Which is 160.
So it's the
It's
same.
Same as hers. So same z-score, right? 1.045.
Yep.
Well, I think we need to divide the normal standard distribution by a square root of 5, right?
Let's see.
Well, but this isn't the standard deviation. This is
Yeah. Look at
Oh,
the-
gosh, dang it. It's the mean, huh? Sorry, guys.
okay. Yeah.
I
I
don't know.
just average of all those, and that was
Yeah.
the 160.
Yeah, it's 160, yeah. Oh, sorry, that's the second time I've done that.
It's okay.
All right.
All right, Devin, I think.
All right, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Rounded answer to 4 decimal places. So what we need to do is find the z-score, which now we can do what I was talking about. So 160 minus 150.8 divided by 8.8 all over the square root of 5 students. So that's going to give, so I got 2.338 for the z-score. Let's see. So 2.338. And they're asking for, what is the probability that they'll have a mean score that is greater than the mean achieved? Okay, so greater than 2.338, I got 0.0097, so 0.010.
This one's rounding to 4 decimal places, so it would be 0.0097.
0.097. Okay.
That's what I got too.
Okay.
Agreed. Okay. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Let's see. Which what is the shape of the sampling distribution of the random variable mean, which represents the sample mean of the 81 students? So I think it would be approximately normal
Yeah.
because it's
Yeah.
a large sample.
Yeah, I agree.
Okay. What is the mean of the distribution of the sample means? Sample distribution for all possible samples of size 81 that could be drawn from the parent population. Okay. So this is where we do what Devin was saying. We do 3.5 divided by the square root of 81.
This is,
This is just a mean, I think, right?
yeah. So every time it asks for the mean, I always get this mixed up too, but every time it asks for the mean, it's just the same mean as the parent mean. So I think
Man,
it's
I did this
3.5.
the last one too.
Yeah.
Why do they keep trying to trick us?
There it is.
Sorry, guys. Okay, so it's just 3.5.
Yeah.
So,
Okay.
okay. What is the standard deviation of the distribution of sample means? And this is that part. For all possible samples of size 81 that could be drawn from a parent population. And so I think that is 0.078, right?
How did you get that?
So sample size 81. The mean is just going to be the mean. We don't have to subtract it, right? So
Divided by.
go standard deviation is 0.7 over the square root of 81. And then, yeah, so 0.078, right?
Yep. 0.7 divided by the square root of 81. Yeah. 0.078. 0.073.
Okay.
Yeah, that's what I got.
Yeah, that's what I thought.
Okay.
So I wasn't quite following there. I thought it was the mean divided by the standard deviation over the square root of 81. Am I
So
doing something else?
the equation that I have is just to get, we're just getting the standard deviation. We're not getting
The z-score.
the sample z. We're getting, it's just standard deviation divided by the square root of n.
So the standard deviation is 0.7, right?
Yeah.
Divided by the square root of 81 is 9. Okay, so 0.0778 or 78.
Yeah, 0.078 is what I
Okay.
got.
I gotcha.
Alrighty. Let's see. 13. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So now we do 3.3. Let's see. 1 second. 3.3 minus the standard mean, or the mean, which is 3.5. Where's the problem? Okay. Yeah, minus 3.5. Going to put all of that over 0.7 divided by the square root of 81. 81, and then that's going to give us a negative 2.57. And they're asking what is less than that. So let's see.
Did you say negative 2.7?
2.571. And let's see, whoops. 2.571. That out. So I have 0.0051.
Yep, and it's 3 decimals, so it's just 0.005, I think.
Okay. 0.005 with 3. Yeah.
Okay, yeah, I got that.
Yeah, so that's it.
Okay, so the next question is, what is the probability that the mean GPA for 81 randomly selected students will be greater than 3.3? So is this the one where we can just go 1 minus our last answer and get 0.995?
Yeah.
Well, what about the area in between?
So it's anything greater than 3.
It accounts for it.
Okay, so 0.9949, 0.995.
Yeah. Yeah.
Yep, I agree there. United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean that was observed in this sample. Now, as extreme or more extreme means that we are not interested in values that are lower than the ones we have observed, but also in values that are far away from the mean, as r is in a positive direction.
Quite the problem.
So we just need above or below? Is that what it means by extreme?
Yeah, so first we need to find the z-score, I think.
So what we're going to do is we're going to do 177.6, and we're going to subtract it from, we're going to subtract 185, right?
Yeah.
And so that will give us negative 67.4, and then we're going to divide our standard deviation squared. Am I seeing that right?
Yeah.
Yeah.
We're going to divide 26.7, the square root of that. Oh, it doesn't look right.
So what did you get on the top? I only got negative 7.4.
Oh, I must have typed something wrong. Okay. Yeah, I shouldn't have such a big number. Sorry. Okay, so then, so you got.
I did 177.6 minus
I
185.
did 117. That's what I did. Okay, negative 7.4, and we're going to divide the square root of 0.7. And so we're going to get negative 1.43. Throw that in here.
I got a negative 1.920 for the z-score.
I got a completely different answer than that. What am I doing wrong here?
Okay, so the top
I got
answer,
1.92 as well, negative 1.92.
Sweet.
what did I do wrong? So
What did
we're dividing,
So it would be negative 7.4 over 26.7 divided by the square root of 48.
Okay, I'm there. I was looking at the wrong z-score.
yeah, I did it wrong.
I did the other z-score. Okay, negative 1.92.
So then if we plug, oh, sorry. I'm going to give this one back to you, Devin. It's all you.
Oh no,
Or whoever it was.
it's me. So
Okay.
negative 1.92 our z-score, and the area. Do we want the combined area above and below?
Yeah, above and below that z-score.
So I got 0.0549.
So
That's
is it, what's the decimal point they want us to round to?
3.
No,
So 0.055.
0.055.
Okay.
Okay.
Okay. Save that problem.
So we missed question 8.
Okay, so that one,
Oh,
I think we get the sample mean of 160 is what we got.
Yeah.
And so do
Yeah.
we take? It might
Oh.
be.
what is the z-score z-score corresponding to the sample mean?
So would we go one? Would be 160 minus 160 on top because the sample mean was 160. That's what we found, right?
Right.
yeah.
Right.
So if we go one,
So do you think it might be 0?
I don't know, sort of, but that just sounds weird.
How do you divide 0?
Let's see.
Can't. Z-score.
Let's see. Is that the only one we got wrong? Was 8?
Yeah,
Yeah.
that's the only one.
I'm gonna. Oh, just a sec. What is the z-score? I'm gonna put 0 just to mess around with it.
Yeah.
And I'll submit it and see. It can't be right though. Yeah, it's not right.
I wonder if it's just 160 divided by the what was it? 8.8 divided by the square root of 5. Dalen, have you submitted yours yet?
I haven't, so I'm willing to try that. So we're thinking to do 160 divided by 8.8 divided by the square root of 5.
Well, let's see. Because from the problem, the distributed mean is 150.8 actually.
Oh, is it?
I think you do 160 minus 150.8 and then divide that by 8.8 divided by the square root of 5. And then tell me what you get.
That gives me 2.337. So 2.338 is the answer I got, and I'm going to submit it.
Sounds good.
Does anyone have all our answers recorded before I do? I don't know.
I kept my
Mine's still open too.
Oh, it kept it? Okay. That was it. 2.338.
2.338.
Okay.
What can we go over what just happened? What did we do?
Okay, real quick, will you keep yours open, Dalen? And let's just write down the numbers real quick.
The answers.
Yeah, the answers.
Okay.
So question 3 is 0.175. 4 is the distribution of the sample means. Sample means, okay. 5 is law of large numbers. 6 is 1.045. 7 is 0.148. What was 8?
2.338.
Yes.
Okay. Question 9, 0.0097. 10 is approximately normal. And 11 is 3.5. 12 is 0.078. 13 is 0.005. 14 is 0.9. 0.95, and 15 is 0.055. That should be it.
Okay. So how did we get the question 8? What did you do?
So, go ahead.
We just did the same thing that we did. It was asking for the z-score, and so we had to go to the story problem to find out what the population mean was, which was 150.8. And so the z-score, or the number that we calculated, was 160. So we just did 160 minus 150.8
Okay.
and went from there.
And then divided 8.8 divided by the square root of 5.
Okay.
That's how we got it.
So before we were just taking two 160s, but it was 150.8.
Yeah.
Okay. Well, cool. Any other questions?
Nope, I'm just filming it in real quick.
I think I'm good.
Okay. Well, I will post these. And yeah.
Got it. I'm so glad we're doing 2 on Tuesday.
Yeah, I like it. I
It,
like it
last weekend was so nice not having to worry about it.
It was nice to have it all done like early in the week, and then I can just worry about my other classes.
Yeah.
Yeah.
Guys, I felt really dumb because I got them all right the first time because and then I went back and resubmitted it, filling them all in. I didn't realize, oh yeah, I already did this. I was the one with the right answer, but here I am, like filling them out. And I get to the end, I'm like, oh, shoot, why should I do this? It's always, well. I felt pretty dumb.
It's funny. All right,
Hey,
dude.
we're taking an exam next week, right?
Yes. So actually, that's something to look at. I can't remember what we do on exam weeks. Let's see. So lesson 8 is just review for the exam. And then lesson 9 is a chapter. So would you guys rather meet on Thursday so you guys have a chance to take the exam first?
Let's see.
Wait, what's the group meeting quiz for lesson 8?
They just have you go through like a review. But I think in my last class, we could just do that one by ourselves. But maybe not. I don't know.
Okay.
So I don't know if he'll post some information about that or whatever, we can email each other. Unless,
Lesson 8. Okay. Yeah. Well, let's see. When's the 31st? This one is due. Is that next Tuesday?
Yeah, the 31st is next Tuesday.
So should we just plan on the same schedule unless he emails us something else?
Sure.
Sounds good.
Okay.
So it'll be next Tuesday.
Okay. Sounds good.
Okay, thank you.
Have a good night, guys.
Thanks. We'll
Thanks,
see you
guys.
later.
All right. Bye.